The very basic EVAP system is composed of the purge valve, fuel tank pressure sensor, and EVAP vent valve. The OVD2 EVAP system closes the vent valve, regulates and introduces a vacuum to the fuel tank, stops the process, and looks to the fuel tank pressure sensor for a vacuum drop. If the vacuum drops too fast, the ACM issues a large leak OVD2 EVAP code. If the vacuum drops slowly, a small leak code is set. If the vacuum holds steady, the ACM passes the monitor test and issues no code. Sometimes, a purge flow sensor is also used. This is a simple temperature sensor-like unit that senses the EVAP flow. By far the weakest component on an EVAP system is the vent valve. This unit is normally located under the vehicle and is exposed to the elements, so its failure rate is very high. The purge valve is pulsated at a specific rate by the ECM to draw fresh air through the charcoal canister. The lower the engine speed, the lower the duty cycle or pulse rate. This two-wire valve is connected at one side to steady 12-volt power through the ignition switch or a relay, and is ground pulsed at the other wire by the ECM. Also, with the system inactive, the ECM expects to see the steady 12 volts through the purge valve coil windings. If not, then it sets a circuit or open circuit code. To test the purge valve, connect a small dome light bulb to its connector, start the engine, and look for a small pulsing light. As you increase the RPM and load, the light pulses will also increase in brightness. If no pulse, using a test light, check for the steady power between battery negative and purged power wire. If no power there, then follow the current to the relay or ignition switch fuse box. The vent valve is an on and off solenoid that seals the EVAP system. It is a two-wire solenoid with one lead tied to steady power and the other to the ACM. It issues an on or off control pulse, not a duty cycle one. The ACM expects to see 12 volts at the signal or pulse side. If not, then it issues an open or circuit code. To test the vent valve, also connect a small dome light bulb to its connector, start the engine, and look for a steady light. The EVAP system is checked with the engine cool. If no power is seen, using a test light, check for the steady power between battery negative and vent power wire. If no power there, then follow the current to the relay or fuse box. The other side of these solenoids is ground pulsed by the ECM. So, if the ECM is missing a ground, it may affect the EVAP components as well. The fuel tank sensor is a 3-wire unit with voltage reference or 5 volts sensor ground connected to pin number 5 of the OVD2 connector and the signal wire. This sensor is a variable resistor piezoelectric unit that changes the output voltage with tank pressure. Most of these units will output 2.5 or 3.3 volts with no pressure, and will increase or decrease the output voltage with pressure or vacuum. Keep in mind that EVAP testing pressures are very low, in the range of 1/4 psi. This corresponds to a maximum of 15 to 18 inches of water. To test the fuel tank pressure sensor, turn on the ignition key and using a multimeter, test the 5-volt reference. If no 5 volts, either the wire is broken or the ACM is defective. Then, using a test light connected to power, probe on the sensor ground. This ground is also provided by the ECM. So, if missing, then the wire is broken or the ACM is faulty. Finally, to test the signal wire, connect a test light to ground and momentarily touch the signal wire. Then, have a multimeter connected to the ACM side and watch for a changing voltage. If you are working on a late model 2004 and up system, you will have EVAP PIDs for the fuel tank sensor. Use the ADP Scan 1 Pro if necessary. If you are working on a Dodge, BMW, or Subaru, your EVAP system then may have an LDP, or leak detection pump. The LDP is a diaphragm-type pump with a vacuum solenoid and a contact reed switch on top. The ACM applies power in a pulsating fashion to the vacuum solenoid on top, which then brings the diaphragm up and down to create pressure on the EVAP system. When the EVAP system inflates completely, the top contact reed switch will stay on all the time. The ACM then looks to this reed switch voltage. If there is a large leak, then the diaphragm will not stay up, and a code is set. If there is a small leak, then the read output will stay on for too short a time, so the ECM will issue a small EVAP leak code. If the reed stays closed for a long and specified period of time, then the ECM will pass the OVD2 monitor test. The vacuum solenoid is a two-wire unit, but the ECM applies power instead of ground. This is a simple on and off solenoid. The reed switch is also a two-wire unit. It simply closes the two contacts, and it may work with ground and 5 or 12 volts reference. To test, you may manually remove and apply vacuum to the LDP. Then, use a multimeter set to continuity to make sure the reed switch is working. Most LDP problems are due to a faulty vacuum solenoid. You may also use a power probe to verify that the solenoid is switching vacuum. Testing an LDP system is a very involved diagnostic due to the time needed. Make sure that you let your customer know and set yourself up for it.